I am Sandeep sir, your new faculty of chemistry. Today I will start surface chemistry. What is surface chemistry? Surface chemistry is the branch of chemistry in which we read about phenomena occurring at surfaces. So deals with phenomena occurring at surfaces or interface. So gas oblique gas, there is no surface. So we will not consider gas interface or gas surface. So first we will learn about adsorption. What is adsorption? Adsorption is the accumulation of molecular species on the surface rather than at the bulk. So this is called adsorbate. Suppose this is metal, solid metal, and gases are getting absorbed. So adsorption is surface phenomenon. So adsorption is the accumulation of molecules on the surface rather than at the bulk. So there will be more concentration of the molecules at the surface as compared to the bulk. So the molecules which are getting adsorbed are called adsorbate, and the surface on which adsorption occurs is called adsorbent. We will see some adsorbent. Charcoal. There are different types of charcoal: wood charcoal, animal charcoal, coconut charcoal, silica gel, alumina gel. These are some of the examples of adsorbent. O3, chlorine, SO2, methane. These gases can get adsorbed on adsorbent surface. So surface chemistry deals with phenomena occurring at surfaces or interface. Gas has no surface. So adsorption is a surface phenomenon. The substance on which adsorption occurs is called adsorbent. The gas or the molecule which get adsorbed on the surface of adsorbent is called adsorbate. Some of the examples of adsorbents are charcoal, 3 different types: wood charcoal, animal charcoal, coconut charcoal, silica gel, alumina gel. These are all examples of adsorbent. Absorption is a bulk phenomenon. So when the molecules are everywhere on the surface as well as on the bulk, then this process absorption is called. Sometimes absorption occur simultaneously. Adsorption plus absorption occur simultaneously occur simultaneously, then this process is called sorption. This process is called sorption. Sometimes both adsorption and absorption occur simultaneously and they cannot be distinguished, then it is called sorption. Suppose this is palladium. Palladium. Palladium is a metal on surface of which hydrogen gas gets adsorbed. This is H2 molecules. So this process is called occlusion. This process is called occlusion. So occlusion is the adsorption of hydrogen molecules on the surface of palladium. On the surface of palladium. So the hydrogen that's adsorbed on the surface is called occluded hydrogen. So it is actually example of adsorption in which hydrogen molecule gets adsorbed to the surface of palladium. Now, what are the different types of adsorption? Types of adsorption. So the different types of adsorptions are of generally two types. One is called the physical adsorption. One is called the physical adsorption. Also called physisorption. Also called physisorption. Another is called the chemical adsorption. Chemical adsorption or chemisorption. Before moving to physisorption and chemisorption, we have to read about adsorption in action, where we will find adsorption. So adsorption in action. When we take some, suppose colored blue ink, if we put charcoal in it, charcoal blue color will get adsorbed. So the solution will become colorless. If you take in a beaker acetic acid, a weak acid, water is there, water is the solvent, and you put charcoal. So concentration of acid in the solution will decrease because it will get adsorbed on the surface of charcoal. Okay. So moisture present in air can be absorbed by charcoal, can be absorbed by silica. So moisture can be absorbed by charcoal or silica. So absorption is a bulk phenomenon, adsorption is a surface phenomenon. Absorption occurs simultaneously and cannot be distinguished, then it is called sorption. On the surface of palladium metal, hydrogen gets adsorbed. This process is called occlusion, and the hydrogen is called occluded hydrogen. We take a vessel in which water is there, water is the solvent, acetic acid is put. If we put charcoal, the concentration of acid decreases because acetic acid gets absorbed on the surface of charcoal. If we take a vessel, blue ink is there. If we put charcoal, the color solution will become colorless because the blue pigments will get absorbed on the charcoal surface. There are basically two types of adsorption. One is called physical adsorption, another is called chemical adsorption. Physical adsorption is also known as physisorption. Chemical adsorption is also known as chemisorption. Mechanism of adsorption. Adsorption is an exothermic process. Adsorption is an exothermic process. Exothermic process in which delta H is negative. Delta H change in enthalpy. So for exothermic process, change in enthalpy is negative. During adsorption, entropy also decreases, so entropy change is also negative. And for adsorption to be spontaneous, Gibbs energy should be negative. This should be negative for spontaneous. From thermodynamics, we know delta G is equal to delta H minus T delta H. This term is negative. Temperature is always positive in Kelvin scale. Entropy change is negative, so negative, positive, negative, 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 positive. So this term becomes negative, this is positive. So more negative the enthalpy change, more will be the negative value of Gibbs energy, more spontaneous will be adsorption. So this should be more negative to make delta E negative, that is spontaneous. So adsorption is an exothermic process. Adsorption is an exothermic process. For exothermic process, change in enthalpy is negative. During adsorption, the molecular randomness or disorder also decreases, so entropy change is also negative. For spontaneous process, Gibbs energy must be negative. So delta G equal to delta H minus T delta H. T is absolute temperature in Kelvin scale. So negative value minus plus minus. So this plus minus will become minus, minus minus is plus. So this negative value should be more to make Gibbs energy negative. So adsorption will only be spontaneous when Gibbs energy is negative. Now coming back to the types of adsorption. There are basically two types of adsorption: physical adsorption, chemical adsorption. Physical adsorption, it involves weak van der Waals force. Van der Waals force. It involves chemical bond formation. Van der Waals forces are weak forces, so enthalpy of adsorption Suppose we take a adsorbent and this is adsorbate. The amount of heat energy released when 1 mole of adsorbent, 1 mole of adsorbate is completely adsorbed on the surface of adsorbent is called enthalpy of adsorption. The amount of heat energy released when 1 mole of adsorbate is completely adsorbed on the surface of adsorbent is called enthalpy of adsorption. Since van der Waals forces are weak force, so in physical adsorption, van der Waals forces are there, so less enthalpy of adsorption. That is 20 to 40 kilojoule per mole. But since it involves chemical bond formation, covalent bond, so more enthalpy of adsorption. More enthalpy of adsorption. That is 80 to 240 kilojoules. It is not specific. It is not specific. Not specific. It is highly specific. For chemical bond formation, specificity is required. So it is highly specific. It is highly specific. This is reversible. This is irreversible. So physics also involves van der Waals force. Chemistry also involves chemical bond formation. This has less enthalpy of adsorption. This has more enthalpy of adsorption. This is not specific. This is highly specific. This is reversible. This is irreversible. Once the bond is formed, it will not be broken. It forms multimolecular layer. It forms unimolecular layer. It forms multimolecular layer. It forms unimolecular layer. So this is the basic difference between adsorption, that is physical adsorption, and